Okay, good day everyone. Today we will be having a summary discussion for lectures 25, 26, and 27, and some FQ hints for FQ number 5 hints for items 1 and 2. Okay. So first, let's go to lecture 25, which involves equilibrium and COG, or the center of gravity. Okay. Recall that in the previous lectures, we have discussed the dynamical motion of rigid bodies. So we are discussing problems involving torques, right? Center of mass, and a moment of inertia, right? So center of mass and center of gravity are kind of the same for that object. So it's similar for that, it's the same point for the same object. But if you have a group of objects or a group of particles, number of particles, right, number of objects, then it becomes more difficult to compute for the center of mass. So we will employ the concept of equilibrium to solve or to find the center of gravity for rigid bodies. Okay. Recall us also that from the previous lectures during the start of the SEM, the Newton's second law, right, dictates the motion of the body or the dynamics of the dynamical motion of a body, right? So meron tayong F equals ma, yun yung Newton's second law, which means meron tayong acceleration, the body has an acceleration, and so it's dynamically moving, right? But then there's this Newton's first law. The Newton's first law again states that a body at rest stays at rest, or a body in motion stays in motion as long as there's no net external force applied to that same body. Okay. So this is called law of inertia, but this has more applications on equilibrium. Okay. So a body at rest, meaning A equals 0. Acceleration is 0. And a body in constant uniform motion, which means the V is constant, the velocity is constant. And remember, the acceleration is just the change in velocity or change in speed over time. Since V is constant, then V2 minus V1 is just 0. And hence, acceleration is also 0. Okay. So here, since we're dealing with equilibrium, we usually not connotate equilibrium with acceleration to be 0. Okay. So, yung system mo, in equilibrium siya kapag yung acceleration 0. It means that the whole system is static, hindi gumagalaw. Or, the whole system is moving at a constant uniform speed. Constancy V. Okay. So, now let's discuss the conditions for equilibrium. Okay. So, an object is in equilibrium if, yung conditions. First, the net force is 0. Again, this is from the Newton's second law. Kung acceleration ay 0, then F equals ma equals 0. Right? Summation ng force must be 0. Kung acceleration mo rin ay 0, so magiging when we apply rotational dynamics or rotational kinematics, right? So A equals R alpha, then that leaves us that alpha, the angular acceleration, must also be 0, right? Hence, the net torque must also be 0. Net torque, summation of torque equals I alpha, but since alpha is 0, then summation of torque must also be 0. So this is the general conditions for objects in equilibrium. Okay. Additionally, for a static equilibrium, again, static equilibrium means the acceleration is, or hindi talaga gumagalaw. Acceleration is 0, velocity is 0 as well. So, velocity is 0. Applying rotational kinematics, V equals R omega. Then we also see that omega must be 0. Okay. Okay. So in general, equilibrium meron kang summation ng force 0, summation ng torque 0. But for static equilibrium, since static siya, ito yung an object at rest, diba? So that is V equals 0 and omega equals 0. In addition to the summations na 0. Okay? Okay. So ito, always true for any equilibrium. Kung static, i-add mo lang tong conditions na to. Yun lang yun. Okay. And again, these results came from the Newton's first law and Newton's second law. Okay. So ayan. So this is a condition for a equilibrium. So if two persons, say Alice and Bob, pushing the same object from a different direction, hindi gagalaw yung box. Right? Either hindi gagalaw yung box or gagalaw yung box at a constant velocity. Right? So if si box gumalaw at a constant velocity to the right, is still an equilibrium. Right? Constant eh. Kung constant si V. Kung hindi constant si V, then hindi siya equilibrium. Okay. Same with this, a hanging mass, right? So meron kang bar. So kapag meron kang bar, tapos may tension dito, may tension, or may tension din dito, tapos may nakahang dyan, that's also in equilibrium. Okay. Okay, so let's provide some examples or exercises. Okay. Consider the mobile below and consider that is in its static equilibrium. Okay. What should be the weight of A and B? Assume that the mass of each rod is negligible. Okay. So, hindi man natin take into account yung masses ng rod. So, negligible sila. So, what do we do with this? This is a system of 3-level mobile, right? So, the best way is to start at the bottommost mobile, right? So, dito muna tayo mag-start sa level na to. So, we have this rod. So, may naka-attach na 6 newtons. Okay. So, 6 newtons. And then, sa kabila, may naka-attach si mass A. And then, nandito yung tension, right, na S3. So, may tension ka dyan. This is 4 cm. And this is 8 cm. Okay. So, here, we apply the conditions for static equilibrium. So, or for equilibrium in general. So, we have summation of torques. So, summation muna ng torque equals 0. So, bakit torque ang gagamitin natin? This is because para hindi gumalaw, meaning kung gusto natin na hindi gumagalaw si mobile, hindi dapat umiikot etong mobile na to. So, wala kang ikot pa ganon, wala ka ring ikot pa ganon. Gets ba? Meaning, etong rod na to, etong rod, hindi siya umiikot on the axis, right? On its axis. Hindi rin siya bababa. Hindi rin parang magsisiso yung dalawang masses. Hindi siya gaganyan, hindi rin siya gaganon. Okay? So, yun yung meaning ng static equilibrium in this condition, in this system. So, dapat naka-parallel lang lagi si rod. Okay? So, with that, kung ayaw mo nang gumalaw, ayaw mo nang magsiso, ayaw mo nang ganitong condition, right? Ayaw mo nang ganyan, yung mass, ayaw mo rin ng pabaliktad, so, dapat hindi nagro-rotate. So, ang i-apply natin, summation ng torque muna. Okay? Summation muna ng torque. Okay. Hindi na mga draw. Ayan. So, summation ng torque. So, saan natin i-apply yung summation ng torque? Dapat dito sa point na to. Okay. Kasi nandito na yung center of gravity. So, for this system, for these kinds of systems sa mobile, yung center of gravity is where kung saan mo kung saan mo gustong mag-steal yung buong rod na yan. Right? Since naka-attach dito yung tension, so dito yung center of gravity na. So, dapat hindi iikot etong mass na to with respect to this point, hindi rin iikot si mass na to with respect to this point. Okay? So, ano yung mga torques natin? Or ano yung mga torques natin? Meron tayong torque due to the 6 newtons, which is yung weight, right? And yung weight, meron ding weight si A, right? So, pareha sila may weight. Ngayon, let's assume na yung counterclockwise ay yung positive direction. Okay? So, counterclockwise, dito. Yun yung positive direction. So, since pababa ito, right? So, counterclockwise siya ay positive. So, meron ka ngayong torque ni 1, torque ni 6 Newton, which is RF, right? Remember, torque equals R cross F or RF sine theta. Okay. So, yung R is the distance kung saan, or distance nung tail nung force, right? Tail nung force from the pivot point. So, ang R niyan is 4 centimeters. 4 centimeters. Times the force, which is the weight. That is 6 newtons. Okay. Times sine theta. Pero, if you can see here, ito yung R, right? Ito yung pivot point. Yung R. Yung weight mo ay ito. So, nag-head to tail na tayo dito. R and weight. So, ang angle between is theta equals 90. Right? 90 degrees. And so, sine ng 90 degrees, that is just 1. Ganon din with all the other cases. So, sine 90 is 1. Okay. Although, dito sa case naman ni A, hindi, same lang pala. Sine 90. Same lang pala. Okay. So, ito na yung torque due to this mass. Okay. Ngayon, kailangan naman natin ng torque due to the other mass, si A. Okay. So, si A naman, meron kang yung mass ni A, ay yung force ni A, yung weight. Let's assume that's weight. Weight of A. So, weight of A. Yan. Tapos, ang distance is this. Yan yung 8 cm. So, this is times 8 cm. Pero, ano ngayon yung sign niya? So, assuming again, positive yung counterclockwise, since ito ay pababa, right? Pag counterclockwise mo dito, mag-opposite siya ng sign, di ba? So, ito yung positive, dapat pataas on this side, yung positive sign. Pero since pababa yan, magiging negative. Okay? So, ito, positive to kasi nandito siya sa left side ng counterclockwise. Ito, negative kasi nasa right side siya ng counterclockwise. So, imagine niyo lang kung ano yung ikot ng positive. So, positive kapag umikot, pag bumaba, sumakyat dito. So, parang ganyan. Yan. So, yan yung positive direction. Anything na opposite dyan will be negative direction. So, you already have this. And this is equal to 0. Kasi nga, equilibrium. So, madali lang natin makuha si WA. Right? So, si WA is just meron ka ditong 8 cm and then equals 4 times 6 24 meron ka na 24 centimeter Newton or Newton centimeters. Right? This is 8 cm. So WA is just 24 divided by 8, which is 3 newtons. So ano nangyari sa cm? Nag-cancel. Kasi parehas may cm. Pag dinivide mo, magka-cancel yung parehas centimeters. So for this, you really don't need to convert. Pero pag kinonvert mo and then kinonvert mo back, 3 newtons pa rin naman yung makukuha. Okay. So now we know that A is 3 newtons. So A is now 3 newtons. Okay. Paano naman si B? Paano natin makuha si B? And si C? So for this, meron tayong next step. So next step is to apply summation of forces. Again, dapat 0 ito. Kasi equilibrium. So saan ngayon natin i-apply? Ito ay na-apply ngayon dito sa point naman ulit na to. So kanina, nag-apply tayo sa same na point ng summation ng torque. Ngayon, summation ng forces. So ano ngayon yung forces that acts on this point? Right? Kanina, dalawa lang yung torque. Right? Ngayon, yung forces naman na nag-act is yung tension at yung dalawang weight. Question or clarification. Kanina, meron tayong torque, diba? Na equals 0. Tapos, yung in-apply lang natin is yung torque due to this and torque due to that. So, bakit din na natin in-apply yung torque due to the tension? Kasi, so meron tayong 6, yung weight ni 6, R, minus weight ni 8, times R, RA, 6. Technically, may effect pa rin naman yung torque due to this tension. So, yung tension ay force, pero yung R mo, since nandyan ka sa pivot point, 0 na. So, wala rin siyang effect dun sa mobile or dun sa summation ng torque. Kasi the torque is 0 distance from the pivot point. Ay, the torque, the tension. The tension is 0 distance from the pivot point. So, wala talaga to. Okay. So, kaya nawala na siya. Ngayon, dito sa summation of forces, kailangan siya. Okay. Again, taking the upward direction to be our positive direction. So, we have tension in S3 or tension 3 na lang. That's a positive. Tapos, negative, yung weight ni 6 newtons. And then, negative 3 newtons. Kasi pababa. Okay. Equals 0. Okay. So, makuha na natin yung tension, which is just 6 plus 3, that is 9 newtons. 9 newtons. Okay. So, ang value ngayon ni tension is 9 newtons. Tension up. Okay. So, meron na tayong 9 newtons. Meron tayong 3 newtons for A. Ngayon, saan natin gagamitin itong 9 newtons na to? We now use the concept of Newton's third law. Okay. The rule of opposite reactions. Action-reaction pairs. Okay. So, hindi naman kailangan masyado mag-isip kasi at this point, ang forces lang na nag-act dyan is yung tension due to this at yung weight due to this dalawa. Okay. So, yung weight ngayon na na-experience ng point na to should be the same as yung tension applied into it. Only on the opposite direction. So, ibig sabihin, yung weight na na-feel nito is exactly 9 newtons. Yan. Okay. So with that, pwede na natin makuha si mass B or si weight ni B. So to weight ni B, similar sa ginawa natin kanina, summation naman ng torques. So ito ngayon si S2. Ito si mass B. Yan. Tapos meron ka dito imaginary 9 newtons. Okay. This is distance 5 centimeters from this. This is distance 3 centimeters from this. And now we apply summation of torques to find the mass of, the weight of B. Okay. So ngayon, summation ulit ng torque. Dapat 0. So again, ano yung forces na nag-act on the pivot point? So meron pa rin tayo weight ni B times 3 centimeters. Right? Times sine theta, but now we know that sine theta is just 1 kasi theta is 90 degrees. And then dito naman meron tayo 9 newtons, pero since again, pag ganun yung positive direction, so dapat consistent yung positive. Ano yung positive at negative direction? So taking counterclockwise as your positive direction, then we get minus negative dapat tong torque due to the 9 newtons located at 5 centimeter. Okay. Again, meron pa rin tayong tension dito. But that tension is distance 0. Has a distance 0 from the pivot point. Right? So, mawawala lang talaga to. So, 0 lang yan. And this is equal to 0 for the static equilibrium condition. Okay. So, here, madali na lang kunin si WB. WB, weight ni B is just 9 newtons. 9 times 5, that will be 45 Newton centimeter over 3 centimeter. So again, magka-cancel yung centimeter. We have 45 divided by 3. That will just be 15 newtons. Okay. So weight ni B is 15 newtons. Okay. Okay. With that, assignment, ano ngayon yung weight ni C? Okay. Okay. Ano ngayon yung weight ni C? Ay, nabura ko na. 15 newtons. Ito ay 9 newtons. Right? Yan. So, ano ngayon yung weight ni C? So, assignment yan. Solve on your own. Okay. Okay. Next problem. So, ito iba namang kind of system. Okay. One end of a 2-meter long uniform stick is placed against a vertical wall. Okay. So, meron ka meter stick, 2 meter long. The other end is held, this end, is held by a lightweight cord that makes an angle theta with the stick. Okay. Ito yung lightweight cord. And there is a coefficient of static friction between the end of the stick and the wall. So, ito yung wall. Tapos, meron kang static friction here. Meron kang mu s. What is the maximum value of theta, the angle, can have if the stick is to remain in equilibrium? Okay. So, dito sa system na to, yung dulo ng stick nakatali here, right? Pero dito, hindi siya nakatali. Nakadikit lang siya, in contact. but there's a static friction between the wall and the stick. So ngayon, ang question, ano ngayon yung maximum angle of theta such that yung stick na to ay hindi gagalaw? Ibig sabihin, hindi siya mahuhulog pababa, hindi siya magro-rotate pataas or pababa. It will stay in that way. Okay. So how do we solve this kind of system? So for this, let's apply conditions for equilibrium. So we have summation of forces and summation of torque equals 0. So in reality, pwede mo naman gamitin kahit ano talaga. Pero in some cases, parang mas maganda na masolve mo muna yung summation ng torque before summation ng force or vice versa. Okay. So kanina, mas maganda na masolve mo na tayo summation ng torque para makuha agad natin yung weights, right? Pero for here, kasi kung mag-summation of force tayo kanina, hindi natin alam yung tension, hindi rin natin alam yung weight. Right? Makuha natin yung isa when we do summation of torques. In this case, we can just use summation of force and summation of torque directly. Okay? So, let's apply the first condition. Sum of forces must be 0 on the stick. Okay? Note on the stick. So, ano yung mga forces acting on the stick? So, meron kang tension, the green ones. Ito yung tension. Meron kang weight ng stick. Okay. Tapos, meron kang friction on the wall and a normal force from the wall as well. Okay. So, meron kang normal force from the wall acting on the stick. Kaya may ganyan kasi in contact sila. And meron ka ring coefficient of static friction. Okay. So, question, bakit pataas yung direction ng friction? Kasi we are expecting, kapag hindi siya equilibrium, pag hindi equilibrium stick, we're expecting that the stick will slide pababa. Right? Kung ang direction of motion pababa, then yung direction of the friction must be opposite to the motion. Right? Kaya naging pataas. Okay. So meron tayong tatlong forces. 1 to 4 na forces. So we have summation along X and summation along Y. So along X, meron lang tayong normal force to the right. So kaya positive. And then, meron tayong component of tension along X, which is to the left. So minus T cosine theta. And dapat yan ay 0. Okay. Along Y, meron tayong tatlo. Si Y component ng tension, si friction, saka si weight. So, meron tayong positive friction, positive T sine theta, and negative weight. Equal to 0. Okay. So, we can simplify. Yung una, we can simplify to get the tension. And that's just N over cosine theta. Yung pangalawa, makuha na natin si static friction. Okay. Now, kailangan natin makuha si theta. Si theta max, right? So we apply. Since wala pa tayong values, hindi natin alam ano si W. Tama ba? Yeah, ang alam lang natin ay length ni stick. Mu S, yun lang yung alam natin. So hindi din natin alam ano si normal force, ano si tension, ano si W, ano si Fs. So we need another set of equation, which will come from summation of torques. The other condition. So dapat 0. Okay. So here we are applying again at the center of gravity of the stick. So same with the summation of forces, diba? So ito yung center of gravity of the stick and we are applying the forces there. Okay, or we are finding the forces on that from the center of gravity. So ganun din with the torque. Ay, joke. Di pala. Okay. So, pwede naman ganun. So, pwedeng from the center of gravity. Pwede rin naman from a different point. Ang magbabago lang naman is yung value of R. Yung distance from the pivot point for each forces. Okay. So, in this case, for this example, yung torques is measured from the red dot. Tanggalin natin. Iba pala. So, from the red dot. This one. Okay. Tama. Dapat pala dyan. Kasi pag in-expect natin kapag hindi equilibrium, iikot yung stick along this pivot point kasi di ba bababa siya. Right? So, pwedeng maging, yung stick pwede maging ganyan, pwede maging ganyan. So, bababa. So, tama. Dito yung pivot point pala. Sorry. Okay. So, with that assumption, doon natin i-measure yung lahat ng torques. Okay. So, alin? Meron tayong 1, 2, 3, 4. 4 forces that contributes to the torque. Okay. So, isa-isahin natin para bago tayo dumating sa ganitong situation. Okay. So, summation ng torque, right, equals, meron tayong tension. So, yung torque 1 or torque due to the tension plus torque due to the normal force plus torque due to the friction plus torque due to the weight. So, meron tayong 4 na torques. Pero, we look at first the torque due to the tension. Right? So, meron tayong RF sine theta. Ano yung F? That is the tension. Right? This tension. Pero, ano yung R niya? Ang distance from the pivot point, since ito yung pivot point, is just 0. Right? So, this is just T times 0. Kaya, mawawala to. 0 na yan. Right? So, wala talaga tayong torque due to the tension. 0 siya. Okay? How about with the normal force? Okay? How about with the normal force? So, yung normal force, ito siya. Right? Ang distance niya is this, that is L. So, let L be the length. Right? Tama. So, L, ito naman, magiging L times the normal force, the magnitude, N, right? Times sine theta. Pero, again, if you can see, dito, ito yung R, from this angle, diba? Ito yung R, ito yung normal force. Kapag inalign natin sila head to tail, ay tail to tail, right? From this position, so pwede natin move si N here. Ito yung R, right? R. And then N. Ano yung angle between? Para sa sine theta. So that is sine 180. Right? Pero sine 180 is 0. Right? So essentially, the torque due to the normal force is also 0. Okay. Now, we have torque due to the friction. Okay. So yung torque due to the friction, erase natin. Sige, okay na to. Ay, yan. Okay. Yan, zero yan, zero. Torque due to the friction, ito naman yon. It's again a distance L. So distance L, and then directed pataas. Pero since counterclockwise yung positive direction, that will now give us a negative sign. So that is negative L times Fs. Ano ngayon yung sine theta or yung sign between the angle? So ito yung R, right? Ito yung Fs. So yung angle between is 90 degrees. Kaya sine 90, 1. Kaya meron siyang value. Kaya siya lumabas dito. Okay. Yung torque naman due to the weight is applied from the center of gravity of the stick, right? So yan ay a distance L over 2, right? L over 2 times the magnitude of the force, which is weight, again times sine theta or yung angle between. Okay, ano yung angle between? 90 degrees. So that will just be 1. Kaya yung summation ng torque is simplified into this equation. Okay. So originally, I'm showing yung complete solution, right? I'm showing your complete solution such that ma-take into account lahat talaga ng possible torques and possible forces. Eventually kasi, for example, yung summation ay yung torque due to the tension, magsi-zero kasi nga yung distance niya from the pivot point is 0. Okay? So R equals 0. Yung torque naman due to the normal force nag-zero kasi yung sign ng angle between the radial vector and the normal force is 180. So sine 180 is also 0. Okay. So kaya sila nag-cancel out. Nawala sa equation. So we are just left with this. Okay. So from that, we can simplify further and get W, the weight, which is just 2 times or twice ng static friction. Okay. So again, paano nangyari yan? L over 2, W equals LFS. Transpose natin. Kakancel yung L. We have W over 2 equals Fs. Lipat natin to sa taas. So magiging W equals 2Fs. Okay. So we now have these 3 equations. Ay, pinakita na yung sagot. Anyway, paano tayo mag-arrive dyan sa sagot na yan? So first, let's look yung equation of the dito, static friction. Right? Alam na natin ngayon si W equals to Fs. So we apply it here or we plug in here, we get this equation. Okay. So I think alam nyo na yung next step. Alam na natin si tension. We now apply it there. Plug in there. Makukuha natin ngayon. Right? We simplify first. Right? 2Fs minus Fs equals T sine theta. So we get this. Alam natin si T. Right? Which is this. Plug in there. So magkakaroon ka na. Wala yung mag-mix. And tangent theta. Paano ulit naging tangent? Meron tayong T, which is N over cosine theta. Right? Times sine theta. Di ba? Ito yung nasa left-hand side. So, meron ka ng N, as yung sine over cosine, that's just tangent theta. Okay? And remember, meron tayong static friction. Okay, so we can apply the condition for the static friction, which is that. Ito. Mu S times N. Okay. If you plug in that, so if you plug in here yung US times N, magka-cancel lang yung N. So meron ka na lang tangent theta must be less than or equal US. And so we can now get our theta kasi alam natin si US, right? And that's how we arrive to our answer. Okay. So for this type of problem, mahaba yung naging solution kasi ang given lang sa atin is mu s and L. Hindi tayo given kung ano yung yung magnitude ng friction mismo, yung angle, yung tension, yung weight, etc. So kaya natin ginamit lahat ng conditions for equilibrium. Okay. Okay, another homework. So meron ng dalawang homework. A block of the same weight as the stick is suspended on the stick at a distance x from the wall as shown. Okay. So meron ka parang similar setup, almost similar setup. Pero ngayon, instead of yung cord lang and yung length ay yung ruler, meron ka ng additional weight. A distance x from the wall. Okay. So here, si ruler, or sa stick, may weight, right? May weight ni stick. And sabi, block of the same weight as the stick. So ito, ang weight nito is the same as the stick. So, weight ng block which is equal sa weight ng stick. Tapos, assume that theta, the angle here is 16.5 degrees. Okay. What is the minimum value of x for which the stick will remain in equilibrium? Okay. So ngayon, ano ngayon yung minimum value ni x? Yun yung hinahanap. Para maging equilibrium yung system na to. And then, given the angle 16.5, how large, again, ano yung maximum coefficient of static friction, ano ngayon si mu s? So, baliktad na. Kanina, hinahanap si angle. Ngayon, hinahanap ngayon si mu s. Okay. Ano ngayon si mu s? So that the block can be attached at 0.8 meters from the length of the stick without causing it to slip. Okay. So for A, hinahanap ano si X. Okay. Ano si X? Ito yung for A. Okay. For B, given naman si X. X equals 0.8 meters. X equals 0.8 meters. Ano ngayon si mu? Okay. So, yan yung second problem. So, it's almost similar to the previous problem, except that meron kang additional force to work on. Right? So, yun, meron kang weight ng ruler, tapos may additional weight ka nung block. So, you work on mo ngayon yung mga conditions for equilibrium with that additional force. Ay, work tuloy. Force pala. Yeah. Okay. Okay. So now let's go to lecture 26, density and pressure in fluid. So here we are just dealing with fluid statics. Ibig sabihin, hindi pa gumagalaw yung fluid. Okay, wala pang flow. So the fluid are just in static equilibrium, quote-unquote equilibrium. Okay. And then we apply yung concepts of density, the pressure, and the Pascal's principle in analyzing fluids in various systems. So Pascal's principle states that the pressure applied to an enclosed fluid is transmitted undiminished to every portion of the fluid and the walls of containing vessel. So this Pascal principle is actually somewhat like a conservation of pressure. So mukha siyang ganun, right? Mukha lang siyang ganun. Pero it works same way as like that. Same way. So for example, meron kang fluid here, right? And then another fluid here, right? What happens is that according to Pascal's principle, yung pressure, lagay natin, red, yung pressure here must be equal dun sa pressure sa kabilang side. Right? So para ka lang nag-P1 equals P2. Okay. And actually, total pressure yan. Kasi, may pressure ka dito. So, kunin mo yung pressure here at the start. Meron ka rin pressure sa interface. Tapos, meron kang pressure dito sa interface ng fluid na to. Right? And then the pressure here kung saan siya exposed. Okay. So, essentially, meron kang sulat ko na lang English. So, meron kang P naught of fluid 1, A na lang pala. B. Plus P interface ni A equals P naught ni B plus P interface ni B. Okay. So it's somewhat like a conservation theorem, di ba? Mukha lang siyang U1 plus K1 equals U2 plus K. Okay. So mas makikita natin yan from our example. Okay. Okay, so shown here is a U-tube in static equilibrium. Okay. So sabihin, hindi na gumagalaw yung hindi nag-change yung height ng water at ng oil. Okay. The oil-water interface is located at the bottom of the tube. The bottom of the tube. Ang tanong, what is the height of the oil column? So ngayon, ano yung height ni oil? Okay. So if static, again, if hydrostatics or static equilibrium yung fluid, we can apply the Pascal's principle at the oil-water interface. Okay. So we have here, sa water side, yung P naught, kung saan siya naka-expose. So yan yung P naught A, is just P naught kasi air lang naman yan. Air lang din to. Okay. So P naught plus yung pressure at the interface. At yung pressure na yan, yung pressure is proportional to rho GH. Okay. So makikita nyo sa main slides na available sa iyo ulit that the pressure is proportional to rho GH. Okay. Rho is the density and G is the acceleration due to gravity and H yung height ng water. Okay, so yung pressure ngayon at the interface, yung pressure na nafe-feel ni water at this interface is proportional to rho GH of that water. On the other side of the interface, meron ka ring P naught A or P naught ni oil. Okay. Pero since same lang na area, so P naught pa rin yung ilalagay natin. And at the interface, meron tayong rho GH naman ni oil. Okay. So since same yung peanut, kasi exposed sila pareho sa air, then yung peanut na yan is equal, magka-cancel out sila. Cancel out. And we are left with this equation. Okay. Okay. So H oil, yung height ni oil is just rho or density ni water times yung height ni water over density ni oil. So magka-cancel din yung gravity. Okay, so we're just left with this. Okay, so again, this only works if yung fluid mo ay static, walang flow. At hindi nagmi-mix. Sabihin, hindi nagmi-mix si water at si oil on the interface. Okay. Okay. Next problem. A tall cylinder with a cross-sectional area of 12 centimeters squared. So ito yung cylinder natin. Right? Sabi niya yung cross-sectional area. So this one, yung area nito, yung isang slice na yan, isang thin slice, is 12 centimeters squared. Okay. It is partially filled with mercury at the bottom. So this one is mercury. Okay. Hg. Hg. Ion G. Yeah. The surface of the mercury is 5 cm above the bottom of the cylinder. So lahat to, mercury, as yung surface nung ay yung dulo ng mercury is 5 cm above the cylinder. And then water is slowly pouring in on top of the mercury. So meron ka ngayong nilalagay na tubig. And the two fluids don't mix. Okay, so hindi sila nagmi-mix on the interface. What must be the volume of water to be added so that the gauge pressure at the bottom of the cylinder should be double? Okay. Okay. Ang tinatanong, ano yung volume of water para maging double yung gauge pressure sa baba. Okay, so here's our problem. So again, we use our Pascal's principle for the pressure. Okay, so pressure is proportional to rho GH. So initially, nung wala pang tubig, ang gauge pressure sa baba ng cylinder, ayan, for both gauge. Initially, nung wala pang water, ang gauge pressure sa baba is just the pressure from the mercury. Okay. Nung wala pang tubig, wala pang water, ito lang yung gauge pressure natin sa baba. Okay? Ngayon, kung nag-add ka na ng tubig, so meron ng H2O, dalawa na yung sources of pressure mo. Okay. Right? So yung new pressure mo, ito yung P old, right? P old, nung mercury lang yun nasa baba. Nung nag-add ka ng bago, ito na yung P new, new pressure. So meron ka ng pressure from the mercury and pressure from the water. Right? So to double the gauge pressure, ano ngayon yung condition? So since ito yung initial pressure natin, gusto nating i-double yan. Right? Gusto nating i-double. So dapat yung P new must be P old or twice ng P old. Right? Twice ng P old. Old pressure. But again, old pressure is yung sa mercury. Okay. And yung P nyo, alam natin, is this. So, dapat, this is P, mercury, GH, plus rho water GH, right? So dapat equal yan. So pag transpose natin to dito, magkakaroon ka na lang ng rho M GH M equals rho water GH water. And so we get this equation. Okay. Again, bakit? Kasi gusto mo yung mu pressure, yung mu gauge pressure, kapag nilagyan mo na ng water, twice no old gauge pressure. Yung dating gauge pressure niya is just sa mercury lang kasi yun pa lang yung laman niya. Nung naglagay ka na ng water, eto na yung bago niyang gauge pressure. And dapat, yung P nu equals twice no P all. So with that, we will simplify into this equation. Okay? So now we can solve for H water. So again, ang tinatanong, ano yung volume ni water such that madodouble yung gauge pressure. So nakuha natin yung condition for doubling. We can now solve for the H water, yung height ni water. Is just the height of mercury times the ratio of the densities. Okay. So again, given tong height mercury, yan yung 5 cm. Okay. So paano ngayon natin makuha yung volume? Okay, nag-plug in muna siya ng values. So plugging in our values, we get this. Now to get the volume of the water, so nagkaroon ka na ng water, alam mo na yung height ni water, So paano natin makuha yung volume? It's just that H, yung height, times yung cross-sectional area. Okay. So sasabihin nyo, volume ng cylinder dapat pi r cube or pi r squared H, di ba? Pero alam na natin kasi yung, di ba? Volume ng cylinder is pi r squared H. Alam natin si H, pero hindi mo na kailangan alamin yung R kasi alam mo na yung area ng isa. So, pi r squared naman na to kasi, yan yung area lang ng isang cross-section, ng isang circle. Diba? So, hindi mo na kailangan alamin yung R kasi given naman yung cross-sectional area sa problem, which is 12 centimeters squared. So, remember, that is 12 centimeters. So, plugging in our values, we get this. That is the volume of water needed to double the gauge pressure. To double the gauge pressure. Okay. Okay. Finally, we go to buoyancy. So this is the final lecture for this week. So here, we will exploit Archimedes principle naman. So dati, kanina, si Pascal. Ngayon, ito naman, si Archimedes. So Archimedes principle of buoyant force is used to solve systems involving fluids and objects that are submerged or partially submerged in fluids. And again, buoyant force is a result of a pressure difference at the top and the bottom of an object. So, kung meron kang fluid, meron kang object, right? Kahit partially submerged or fully submerged, may pressure applied on the top and at the bottom. Okay. Same here. So, may pressure ka at the top and at the bottom. Okay. Technically, may pressure ka rin on this direction. Okay. On this direction. Yung nandito. Pero hindi naman siya nagte-take into account for the buoyant force. Okay. Normally wala siyang effect on the buoyant force kapag we assume a very very simple systems. Okay. Pero in reality, again, may pressure pa rin dito. Nagka-cancel out lang siya kapag we talk about simple systems or buoyant force applied on very simple system or simple object. Okay. Example, a 15 kilogram solid gold statue is raised from the sea bottom. What is the tension in the hoisting cable? So when the statue is at rest and completely underwater. Okay? So meron ka ngayong statue na naka-immerse underwater, which is a seawater. Okay, seawater. And completely at rest na siya under the water. So again, we are dealing with static equilibrium. So completely at rest, so this is a static equilibrium. Okay. So given tayo ng density ng gold, kasi solid gold, density ng seawater, and density ng air. Okay. Nandito na rin yung free body diagram of the statue. So underwater, meron kang tension from the hoisting cable. Meron kang weight of the gold statue. And of course, yung buoyant force due to the pressure difference from the top and the bottom. Okay. Which is denoted by B. Okay. So how do we solve buoyancy problems? Again, remember, static equilibrium siya. So we can apply summation of force equals 0. Right? Kasi in equilibrium at rest. Again, pag at rest, static equilibrium. Kapag sinabing moving yan, magkakaroon ka ng MA, something. Pero since at rest naman siya, and hindi gumagalaw, ang sabi? Yeah. Hindi gumagalaw. So, summation of forces equals 0. So, meron ka ngayon 3 forces. Tension, force, a buoyant force due to the seawater, and then weight both. Okay. Again, negative yung weight kasi opposite direction. Okay. So, ang tinatanong, si tension. So, we can just isolate tension and work the right-hand side equation. So, right-hand side, weight is just mg. Alam natin yung mass, given siya, 15 kilograms. Tapos, yung buoyant force will just be rho vg. Okay. So again, according to Pascal's principle, yung pressure is rho gh. Ito yung Pascal's principle. From the Archimedes principle naman, we get the buoyant force, so FB, equals rho g v, the volume of the submerged. Okay. Rho ng fluid, ito yung volume ng nakasubmerge. Okay. So remember these two important equations. So from Pascal's principle and from Archimedes principle. Okay. So here we have for the buoyant force, density ni seawater times the volume nung nakasubmerge times G. Okay. Pero hindi natin alam kung ano yung volume ng statue. But we know its mass and its density. Kasi alam natin yung density ng gold. Assuming na pure gold siya. Okay. So again, rho ng gold equals mass over volume. Right? So yung volume ng statue is just mass over rho. Ito yung mass ng statue. Ito yung rho ng gold. And with that, we can now plug in this. Plug in that here. Okay. So lahat ng ito, alam natin, 15 kilograms. Alam natin si G. given na si C water at si rho ng statue, which is rho ng gold. Right? So we can just apply everything or plug in everything and we get 139 newtons. Okay. Next example, a block of density 800 kilogram per cubic meter floats face down in a fluid of a density 1,200 kilogram per cubic meter. The block has a height h of 6 cm. So alam natin yung height h. Okay? So makikita natin from the figure, partially submerged ngayon si block. So ang tanong, A, by what depth h, small h, is the block submerged? Ano ngayon yung height ng block na nakasubmerged in water? Kasi partially submerged na. And for B, if the block is held fully submerged and then released, what is the magnitude of its acceleration? Okay. Let's first solve for letter A. By what depth h is the block submerged? Okay. So since dito wala pa tayong ginagawa, wala pang ginagawa. Excuse. In-assume that the block is at rest. And since the block is at rest, we can apply conditions for equilibrium. Summation of forces is 0. Okay? Pero ano lang ba yung forces acting on the box or on the block? Right? Dalawa lang yan. Buoyant force and the weight. Wala kang tension kasi hindi naman siya nakasuspend. So meron ka lang FB minus W. It just means FB was W. Applying Archimedes principle sa buoyant force, we have rho ng fluid times V submerged, G equals mg. Ngayon, partially submerged lang si block, right? Remember? At yung nakasubmerged lang sa kanya is yung cross-sectional area, sabihin natin A, times yung H. Okay? Times yung height. So yung volume na nakasubmerged is just A times H. Okay. Pero ngayon hindi given yung cross-sectional area, right? But we can work that out from the total volume of the box. Okay. So yung total volume of the box is A, yung total volume, V total of the box is A times capital H. Right? Yung area na to times this, para ka nang length times width dito, tapos times height na to. Yan yung total. Okay. So ano ngayon yung portion na nakasubmerge? So yung V submerge actually is just V submerge is just ito pala. Ay, okay. Ito? Rho equals mass over V, ay, wait lang. May na yung V submerge. Itong V total equal to sa mass over yung rho or density ng box, right? So again, bakit? Kasi galing siya sa rho equals mass over volume. And yung volume total is AH. So this is just A capital H. Okay. So from this, itong equation na to, we can find yung A. A, capital A is just M over rho H. capital H. Okay? Kaya, makukuha natin yung ito for A. Okay? Okay, so dito nag-apply lang tayo ng definition of density. So, mass over volume. Ito yung total volume, right? So, we can get yung cross-sectional area A by isolating it there. Tapos, yung M over rho H, pinasok natin dito sa A. Tapos, may H ka pa doon. Kaya may small h ka. Ngayon, nag-cancel na si G. Okay? Kaya, ganito na lang yung naiwan. Okay. Given ba 0? Wait lang. Okay. So given pala yung density ng block. Kaya okay. Okay. So given yung density ng block saka density ng fluid, that's why we get here. Okay? So now we just plug in our values and solve for H. Alam natin yung mass. Ay, magka-cancel lang yung mass. Alam natin yung rho and rho saka yung H. And we get the small h. Okay. Okay. Now for letter B, if the block is held fully submerged and then released, what is the magnitude of its acceleration? So ngayon, hindi na summation of force equals 0 kasi meron ka ng acceleration. So ang ginawa mo, nilubog mo fully yung block and then nirelease mo yung hand mo. So slowly magpo-float up against the block. Right? So ano ngayon yung magnitude ng acceleration na to? Okay. So when the block is released, we have summation of force equals MA. Again, di na siya 0 kasi hindi na siya equilibrium. Umaangat na yung block after mong ma-release. Diba? Mag-float ulit si block. Pero parehas pa rin yung forces natin. Buoyant force and the weight. And so, if we apply Archimedes principle, we have this equation. Again, for now, hindi na 0 yung right-hand equation. Right? Pero alam na natin yung V sub. Again, bakit? Kasi na-calculate na natin si small h kanina. Okay. If the... right. Kasi ngayon, fully submerged pala. So, fully submerged and then released. So, fully submerged na si block, tapos nag-accelerate siya pataas. Okay. So, since the block is fully submerged, we just use for V total, M over rho. Again, that is just rho equals mass, rho ng block, equals mass ng block over volume ng block. Ito ngayon yung volume na nakasubmerge. Buo na siya nakasubmerge. So, it's just mass ng block over rho ng block. And that's why we get this. So, alam natin yung mass, alam natin yung rho, we can just plug in our values and isolate acceleration, and we get 4.9 meters per second squared. Okay. Okay. Next exercise. A rock is suspended by a light string. When the rock is totally in air, the tension of the string is 39.2 newtons. Merong tension. When the rock is totally immersed in the water, the tension is 28.4 newtons. Okay. When the rock is totally immersed in an unknown liquid, the tension is 18.6 newton. What is the density of the unknown liquid? Okay. So meron kang given tatlong tension. Tension in air, tension in water, and tension in the unknown liquid. Tinatanong ano yung tension of the or density of the unknown liquid. Okay. So here we can assume again na hindi gumagalaw, right? After immersion, after immersion in the water or in the liquid, assume natin na hindi gumagalaw yung rock. So with that, we can apply conditions for static equilibrium or equilibrium in general. So summation force equals 0. So dito, tatlo yung force natin. So in air, okay, in air, we have this equation, right? Pero ano yung buoyant force in air? We just have, again, rho Vg, rho ng air, V ng rock, times G. Okay. Then in water, we have this, right? Rho ng water, V rock, and G. Okay. So from this equation, we can isolate volume ng okay. So we can get volume ng rock, right? Or, pwede pa lang, pwedeng, from this equation, i-transpose natin si mg. So, equal na siya sa mg, right? Itong T water plus raw water equals mg, right? We can also do the same in here. So, dito magiging T air. Meron kang T air plus rho ng air, Vg equals mg. Same with sa water. Okay. So, same with sa water. Rho Vg. Ito ay sa water naman. Ay, V. G equals mg. Okay. Since same sila ng mg, pwede nating i-equate both of these equations. So it now becomes T air plus rho air V rock G equals T water plus rho water V rock times G. Okay. And with this, we can isolate V rock and get this equation. Okay. So we can now plug in our values and get the volume of the rock. So alam na natin yung volume ng rock. Ngayon, ano ngayon yung ang hinahanap, ano yung density ng unknown fluid. So with that, we will use same assumptions, right? So meron ka pa ring tension plus buoyant force minus weight equals 0. Okay, for the air. Okay, so alam na natin yung volume ng rock. We can get the weight, which is just 39.2 newtons. So mag-0. Okay. Plug in lang yung values. Alam natin yung raw air, alam natin yung V rock, alam natin yung tension sa air. And we get that. So bakit natin kailangan yan? Kasi when the rock is totally in the unknown liquid, we get the same equations for the unknown liquid. So kailangan natin ngayon si V rock sa kayong weight. Right? At sinahanap is raw liquid given yung tension. So with that, we can isolate density ni liquid, right? And then plug in our values and get 1.91 times 10 cube kilogram per cubic meter. Okay. Okay, so as a homework, answer this. For your science exhibit, you want to make a block of wood float at the interface between a layer of oil of unknown density, raw oil, and water, which is 1,000 kilogram per cubic meter, inside the container as shown. The density of the wood is given by 850. What must be the density of the oil? Ano ngayon yung raw ng oil? So that the only 30% of the wood is submerged in water. Okay. So yan, may tatlo kayong exercise. Yung una, get the weight of C dun sa mobile problem. Pangalawa, yung may additional weight ka dun sa sa stick and cord system. And then this will be your third homework. Okay. Okay. So let's go to FQ hints for number 1 and number 2. Okay. So number 1, left side, right side. A ladder of negligible mass composed of 2 L long rails. So ito yun. Ladder. So distance L to, both, that are hinged at the top and is placed on top of a frictionless floor. So wala akong friction dito. A metal bar connecting both rails halfway up the ladder is placed so that the two rails make an angle of theta 42 degrees at the apex. Okay. So meron ka ngayong pinage dito na connection such that meron kang theta equals 42 degrees here at the apex. Okay. Lastly, a mass of 4.2 kilogram block is placed 2/3 of the way up the ladder on the left side. Okay, as shown. A, what is the magnitude of the tension in the metal bar? Okay, so ano ngayon yung tension dito sa metal bar? Tension. Okay. So tip, assign variables at different points of the ladder that are relevant. So meron ka ngayong different points. So bottom, middle, and top on the left side, and then bottom, middle, and top on the other side. Okay. Assign a positive direction for your rotation and linear motion. So, pwede mong i-assign na ganito yung positive, counterclockwise, pwede rin pabaliktad. Okay. And then, as well as yung sa summation of forces. So, that is for summation of torques. Tapos, sa summation of forces, right? So, assign a positive y-axis, positive x-axis, etc. Okay. So, ito yung rotation, linear motion. And so, you write Newton's second law for linear and rotational motion for both sides of the ladder. And use this system of equation to solve for the tension of the metal bar, T. Okay. So actually for this, medyo similar siya dun sa mobile problem, except that yung tension mo is pag ganito. So meron kang summation of torque, summation of force, static equilibrium, and then apply. Okay. So meron kang Newton's second law on the left rail, on the left. Tapos meron ka rin Newton's second law on the right. So magkaiba. Okay? And then, important again, yung labeling ng different points para malaman nyo kung saan ba i-measure yung distance of the force kapag nagsasummation ka ng torque. Okay? Kasi torque is RF sin theta again. So yung R will be based on kung saan kayo kumuha ng pivot point. Okay. B, what is the magnitude of the normal force exerted on the bottom right side of the ladder? Okay. So ito ngayon yon. Kasi meron kang tension dito. Negligible yung mass, so wala kang weight nung ladder, pero may weight ka nung block, right? May weight yan. Pero, since in contact ito with floor, meron kang normal force. Same with here. Okay. So ngayon, ano ngayon to? Ito yung tension, weight. Ito yung tension. Ito yung normal force. So ngayon, ano to? Yun yung B. Bottom right side. Okay. So for this, you can use the tension from part A and the equation of motions to solve for the normal force on the bottom right side of the ladder. Okay. Again, frictionless naman yan, so walang friction, right? Frictionless. Meron ka lang normal force kasi in contact siya with the floor. For letter C, what is the magnitude of the normal force exerted on the bottom left side? So for B, ano ito? For C, ano ito? Right? And then, so again, you can use your equations of motions from A. Yun lang yung gagamitin mo. Same for letter D. So sa letter D, what is the magnitude of the force on the right side of the ladder exerts on its left side? Okay. So again, A, tinatanong ano yung tension. Ito yung A. Ito yung B. Ito yung C. And then yung D is ano yung total force, magnitude of the total force of the right side exerts on its left side. So again, ito yung total force na ina-exert ni right side kay left side. Okay. So ano yung mga forces na yan? Marami yan. Okay. Number 2. Lubog sandwich. A cubical block of wood with side length L equals 12 cm floats at the interface between some liquid, okay, and water, with its lower surface D 7 cm below the interface. Okay. So ito yung figure. So 10 cm, 10 cm, plus D is 7 cm. Okay. A, what is the gauge pressure at the upper surface of the block? Okay. So recall that pressure is P naught plus rho GH. Since we are looking for the gauge pressure, P naught is 0. Okay. So again, ito yung total pressure at yung gauge pressure is just this. So P naught is 0. Okay. Obtain the depth of the upper surface of the block from the figure to get H. So ito yung H na gusto mong hanapin. For that, ito yung kasi gusto mong makuha yung gauge pressure on the upper surface. So iba yung distance na yan. So ito yung H. Okay. Note that the upper surface is only submerged in water. Hindi siya kasama dun sa other liquid. Okay. For B, what is the gauge pressure at the lower surface of the block? So again, nakuha na natin yung H kanina sa taas. And then we can use that kasi note that there is water pressure above the lower surface of the block. So ito yun. May pressure ka dito above the lower surface of the block. So may water pressure ka dyan. This means that the total pressure here will be due to both the water and the liquid, but with different values based on their depth. So, similar yan dun sa ginawa natin kanina. Dun sa cylinder na may mercury. Diba? So, yung gauge pressure at the bottom kanina, diba? Yung bago, kapag meron ng water, may water, tas may mercury, is the pressure from the mercury plus yung pressure from the water. So, dito, similar din. Yung pressure ngayon, yung gauge pressure at the lower surface will be the pressure from the liquid plus the pressure on the interface or the water, due to the water. Okay. For C, what is the mass of the block? So ngayon tatanong yung mass of the block. For this, you can use Newton's second law to get an equation of motion for the block along the vertical direction. Okay. There are three forces: the buoyant force of water, the buoyant force of the liquid, and the weight of the block. Again, note that the block is in equilibrium. So we can apply conditions for equilibrium and then solve for the mass of the block using yung mga values from A and B. Okay. And with that, alam na yung mass. What is now the density of the block? Okay. So since partially submerged siya in both water and liquid, we get the density of the portion of the block submerged in water. So meron kang density of the block in water. And then we also get the density of the block submerged in the liquid and just add them to get the total density of the block. Okay. So get this, the portion submerged in water and then submerged in liquid, and then we get the total B. Okay. Okay, so that's it, I think. Remember yung 3 exercises? So I will send naman yung copy din ng exercises para meron kayong reference as well as the homeworks. Okay. So that's it. Thank you for listening and good luck.